Thank you very much. So it sounds like my mic is working. That's good. Good start. So I am going to be talking about serverless architecture for augmenting WordPress. If you are not familiar with what serverless architecture is or how to use it, hopefully I will explain a little bit of that as we go, and then using it through a case study. So not super specific, but a general kind of one thing we've done to use serverless architecture with WordPress. So to set the scene a little, covering some of the limitations of traditional platforms, particularly when it comes to things like responsive images. Some of the challenges with responsiveness, you've got many devices, many sizes. This, with images in particular, means you have to store all of these different sizes of the same image. If you happen to change the sizes that you use on your website at some point, you might have to regenerate all of those. And if you don't clean up after that, that means you have two sets of multiple sizes of the same image potentially and things. And then there's a lot of bandwidth going out. You've got huge amounts of traffic potentially, and so they're all downloading large images multiple times sometimes. And that can be the actual processing of those images to generate smaller sizes can be quite intensive. So the problem, many sizes, a lot of traffic, many devices, it means lots and lots of images. So this particular problem that we've faced in hosting, so I work at HumanMade, I look after our hosting and infrastructure stuff, and we have one client that runs a couple of large blog networks. So there's two separate networks, and they do in excess of 8 million page views per month each, and their niche that they tend to focus on is fashion, foodie, lifestyle stuff. So you can imagine super high-res photos of food, super high-res selfies, people dressed up all nice and then looking super casual and candid, in a setting somewhere where they've taken a nice photo. Lots of those, and then you have many blogs, many bloggers, and there's lots and lots of these photos getting uploaded. So we have in excess of 2 terabytes of images. This blog network actually has been running for a couple of years. 2 terabytes is not huge, but it's growing pretty fast. So how do we deal with that? We have to process all of these images, and these are high res. You think the best digital SLR you can get at the moment and the megapixels that can take. Uploading one of those, storage, the bandwidth, generating multiple sizes, and then dealing with all of that. So that processing as well can be super intensive. But if you imagine you have 2 terabytes worth of high-res images and you change the sizes used in the WordPress theme you're using, and then you regenerate those, you could well bring your server to its knees just trying to generate all of those. So with WordPress, since 4.4, it now handles the sizes for responsive images natively, so it can actually specify this stuff in line using the data source stuff. And that can, obviously WordPress can also handle creating the multiple image sizes here. But it doesn't really solve the entire problem at this level. You can't make things scale necessarily because you're still doing all your processing in one place and you're dealing with it all through a single system. So what are some of the solutions that we've used at HumanMade in a large-scale environment to deal with this issue? And it's kind of progressed. So initially, we created a project called Tachyon, and it deals with image resizing on the fly. And we called it Tachyon because it's supposed to be faster than light image processing. Tachyon's the name of a particle of light. So it was inspired and forked from WordPress.com's Photon, which does similar. So if you have a blog hosted on WordPress.com, then it uses their Photon system, which is basically a content delivery network with on-the-fly image resizing. So this gets rid of the problem of having to generate multiple image sizes ahead of time, particularly when you may not know all the devices you want to support. So a new device comes on, you don't have to generate a new image for that different size device. All you do is you update WordPress, you tell it to display it at this, and then when it requests the image is generated then and sent back. So Tachyon was forked from Photon. Photon is built on PHP. It uses the graphics magic engine for regenerating images. We switched over to that to use ImageMagick, and we hosted it on AWS. So we use AWS for all our hosting. We already have moved to the step of, at this point, putting all image assets onto S3, which is Amazon Web Services storage, simple storage solution, and it basically has, I think it's had like 96% uptime or 99% uptime since 96 or something. So it's super, super robust. And if you wanted to, let's say you have something you're expecting to get a lot of traffic on, you pop it onto your image onto S3, or maybe it's a PDF download or a movie download or whatever it happens to be. You pop it onto S3 and it can get absolutely pummeled by the internet at large without affecting the processing of your general web page serving, right? So you're separating those concerns out. So in this case, we already have images stored on S3, and we use the CloudFront CDN. So we've got a few sort of improvements there, and then we added this into the mix to automatically generate those multiple image sizes on the fly. WordPress doesn't know about Tachyon out of the box. So if you want to use WordPress.com's Photon, you have to install Jetpack and all of the things that come with that. And so you can use that on your self-hosted site, and then it will use Jetpack to redirect image requests basically to WordPress.com's infrastructure and Photon. And so we had to build a plugin to do the same thing with Tachyon. So this handles the rewrites of URLs so that all the images stored on S3, instead of using the big long AWS sort of URL that you might have for an S3 stored image, it goes through Tachyon instead. And so it basically says to Tachyon, I want this image. Tachyon goes to S3, grabs it out, generates the right size, and sends it back. WordPress itself handles the specification of what that size might be based on the image sizes you've defined in your theme or plugin or whatever is working there. So this was the initial version we had was Tachyon, forked from Photon, running PHP on a server, and then this plugin. And we decided to take it a step further, and we rewrote Tachyon in Nodejs. It's faster, has better threading, so if you've got a lot of requests coming, a lot of images being processed, it uses Sharp for image processing, which is pretty baller. That's even better again than ImageMagick, basically. And one of the cool things, so this deprecates the PHP version of Tachyon. These are up on our GitHub repo, so you can have a look and poke around if you're interested. If you look at the PHP one, consider it a deprecated project. Don't use the PHP one, use the Node.js one. So it runs, JavaScript is the future, and it runs on a server, and all the requests that come in, so if you think of it, request comes in, hits Tachyon on a server, which is running Node.js, hits S3, grabs the image, generates the new size, sends it back. The problem is that when you're doing a lot of image processing, you need a quite powerful machine to handle a lot of requests, to resize, large high-res photos of food all at the same time. So one good thing about it being in Node.js is that we can actually make this run on Lambda, which is another AWS service. So if you're not familiar, it's essentially their tagline is run code without having to think about servers. So if you think about AWS, if you've used it before or not, AWS is a cloud hosting type provider, and it generally runs, you have EC2 instances, which is just a virtual web server, and you can have multiple ones of these, and you can think of that pretty much like a machine that's sitting there running a web server. And you essentially pay for that in hours used. While you have that machine there and running, you're paying for every hour it's up. 0.05 cents or something, right? It's not expensive, of course it adds up, particularly if you have multiple of them running one application. And you're paying for that time. You kill the machine, you're no longer paying. You spin the machine back up, you're paying for however long you use it. And so it sits there being a web server. The cool thing about Lambda is you're no longer renting a machine time, you're actually renting processing time on a machine. So you don't have the whole server, you don't care at all about the server, you just say, here's a piece of code, run it. And it runs it, and you pay for those nanoseconds, and that's it. You don't need to worry about the machine. And it can run Node.js, Python, and Java. I'm not sure why you'd want to do Java myself, but Node.js, it's not lightning fast on this thing. So Tachyon running on Lambda. It's serverless, almost. It's very close to serverless. Serverless is like massive buzzword in cloud hosting at the moment. It's almost serverless. At the moment, you still need the server, but it's just running Nginx. It's a thin proxy, essentially, and that's due to a technical limitation of AWS API Gateway, which is another service of Amazon's. And so it can't return binary data for images, basically, is the problem. It needs to return a string of some kind, and images aren't a string. So you just have a really thin Nginx proxy as the machine, which you pay for, but it can be the smallest machine size available for AWS. It doesn't have to be big at all. It's literally just passing requests back and forth and doing nothing else. And so Lambda makes this thing inherently scalable, because if no one is requesting images from your website, Tachyon is not running. It's not doing anything. There's no server somewhere running Tachyon. It's just, you're not paying for any of that. And then you might get really spiky traffic. So suddenly you have 2,000 people all trying to leave a photo comment on a blog post or something, and Lambda just handles that, takes all those requests. It literally is you're just renting that processing time on the machine, and then it stops and goes away, and you only paid for that spike, instead of having to have a large, powerful machine that can do image processing really fast, sitting around doing nothing for 7 hours a day or whatever it happens to be. So just to help visualize this infrastructure, and in particular how web infrastructure as a whole has kind of evolved, right? So originally we started with, you've got a web server, the user makes a request, WordPress is running on there with PHP, MySQL, all your files are stored there, everything is running on there. This is probably how you do a lot of your local development. It's probably how, depending how long you've been in it, it's probably how you ran your first website. And then at some point you might have decided, look, I'm going to separate the database server out from that. So my PHP runs in its own processor and memory and all that stuff, and my database gets its own processor, memory, maybe more. Separate those concerns out. And then you might have gone a little further again for optimization, popped a content delivery network in front, so that way your server doesn't get pummeled for every request. There's some caching happening up the front there. Images are cached in there. If you don't know how a content delivery network works, it's essentially servers all around different locations on the planet that just keep the image or the rendered HTML that comes out of your WordPress web server, and they hang on to it for a little while so that it's faster for people who are local to that area. And then maybe you do what I mentioned earlier, and you move your images and static assets and things into S3. So that means that if you are getting high traffic and your server's getting pummeled for requests, all those requests aren't leading to multiple more requests of images that your server has to handle while it's trying to generate PHP-based pages. And it's getting time taken up trying to serve images and various other static things that it needn't be worrying about. You take advantage of S3, then that's quite a super robust system to handle that stuff. And then with Tachyon, it's further again, and so now you've split out some of your static assets like PDFs, movies, documents, other things like that are still S3, and then you have Lambda that's purely looking after your all the images as they come out. So it goes super fast. Your CDN takes takes the brunt of that traffic and maps everything. So all the URL requests, you don't have all sorts of crazy URLs going on here. You just point the URL you want at your CDN, so your primary domain, and then you tell your CDN, okay, anything from uploads that is an image that ends in JPEG or PNG or something, send that request off to here, send the request for documents and things here, and other web requests to the main server, and you've split everything out. So your web server can focus on processing PHP and all of that kind of stuff. And it's super fast because you get, out of this, you get every time someone requests an image, regardless of the size, if it's not been requested before, then it gets generated super fast by Tachyon, and then it's stored in the CDN. So you're never storing those multiple image sizes. There's no need to store them, other than what WordPress will. You'll need to disable WordPress generating some of those if you don't want to keep them at all. They can be good for a fallback. But if you suddenly change sizes, you don't have to wait for your website to regenerate a whole bunch of things automatically. If that image has not been visited before, it'll get created and stored in the CDN, so you don't even have to worry about storage for that at all, because you generally don't pay for storage in the CDN. You pay for traffic over the CDN. And because those images are optimized to the size they're being requested, you're not paying any more than you need to. So the end result of this was, okay, that's cool, it's fun, it's technical, it was super fun to make it and build it and go, is this gonna work? Oh yeah, awesome, and then try these different things, and oh, we can make it even better if we do this, and pop it in Lambda, and Lambda's exciting to play with. So, but does the customer care? Like, we explain this to the customer, and the customer's like, cool, but what does that mean? And so, well, they save a lot of money on storage, generated on the fly, stored in the CDN. It's a lot faster for visitors. More devices can be covered. If you have super high traffic, then all it takes is the very first person to hit that image, and suddenly it's generated, it's being stored in the CDN, it's being propagated across the planet into those different edge locations for the CDN, and everyone else who goes and requests that image has a super fast experience. Saving money on processing, because there's no EC2 instances sitting around, which is pretty fantastic. Ultimately, it comes down to better user experience, cost saving, and you're also preparing yourself for freeing up WordPress processing for other things, and WordPress can just deal with the things that WordPress is the best at. And it was super fun to work on. So that's serverless architecture for augmenting WordPress. Thank you.
Okay, any questions?
I spoke super fast then, sorry.
I understand the great talk, and I'm really interested in serverless architecture. Just a quick question, you said you had 2 terabytes of images. Obviously, there was that one day when you went live. What did you use to warm up the structure? So essentially, you're not going to put 1 million users to generate the images at once.
Sure, yeah. So warming the cache is not really necessary in this particular scenario because they're on the fly and it is really fast. It's not necessary. Even if your first few hits still all get through the cache and hit Tachyon, because it's so fast, it doesn't matter. It might be fractionally longer for those particular users to wait, but it's not noticeable, yeah.
Hey, you mentioned swapping over to the serverless architecture. It saved a lot of money. Do you have exact figures on how much money you saved?
No, actually, no. I know that we were, yeah, no, I don't have any exact figures. But if you think of it as being, web traffic is inherently spiky. You have short periods during the day where you're getting a lot of traffic, and you have the rest of the day where you're getting like a decent amount of traffic. So let's say everyone jumps on in the morning and they want to see what their favorite fashion blogger has been doing, and they look through a couple of posts there, and then they jump off. And then throughout the day, people kind of just gradually trickle in, organic traffic, people checking back in to see what they had for lunch or whatever, and then that's about all. And then overnight, people are sleeping and things like that. So there's not that many websites of this particular nature that'll get high traffic 24 hours. And so by literally your usage, when you're renting processing time, like in something like Lambda, your usage is following those spikes precisely. And so given the pricing difference, unless you were getting super close, it's always going to be more effective to do something like that than have a high-powered machine that's just sitting there running regardless of what's happening all the time. So I don't have exact figures, and it would vary from case to case anyway, but yeah, we save significantly on it.
Why did you choose Sharp in your Node implementation?
Sure. Essentially, that was based on the general adoption more than anything. So we knew that Sharp was good because we'd used it on a couple of other things before. And then when we were doing this, we were like, oh, let's just double check and see how it goes. And so we looked at benchmarks, we looked at activity on the project, the open source project itself, and we looked at how many other projects use it. So you can think, okay, so it's getting a lot of activity now, but what happens if the core team who are building this particular open source product all decided to, maybe they all get hired somewhere and they're, oh, no more time to work on Sharp. So if there's a good community already around it, there's more likely to be adoption and it will still continue, right? So it was mostly factors like that, yeah. Cool.
Just one last question. I can see where if you're not trying to resize, you don't need to worry about the compute in the cloud. What about for podcasts or videos that you might host? If you're not a big hoster, maybe you don't want to source that out to another platform, but you've got to get a bit of content that's either, say, a monthly podcast or a occasional video. Would you use a similar model minus the compute resizing?
Yeah. So in the case where you were using, let's say, non-image based assets, you would still use this setup. Yeah. I mean, probably you're going to have some images, so arguably it might be still good to go with this one, but if you're just using other assets, I would still want to offload them to S3 at least, for sure. Yeah. It's just so much more robust, and if you're expecting a lot of people to be downloading your podcast, for example, the storage is cheap on there, so you don't have to have a large, expensive hard drive volume attached to your server, for example. You just have a relatively small hard drive on your server because all your storage is in S3, which is very cheap storage. You get an element of revision, the bandwidth is cheaper, and because it's so robust, people could absolutely hammer the URL for your podcast because you're mega popular and you won't flinch. Not your problem, ultimately. It's AWS has got to keep S3 up for everyone.